In this section, we will begin solving algebraic expressions. Now, to solve an equation means to find the value of the variable that makes the equation true, that makes the statement true. Here, the definition is written: to solve an equation means to undo all of the operations of the equation, leaving the variable by itself on one side. Now, if you think of undoing an operation, if you have addition, the operation that undoes addition is subtraction, and vice versa. If you have subtraction, the operation that undoes that is addition. If you have multiplication, the operation that undoes multiplication is division, and vice versa. So we want to undo all of the operations in the equation, leaving the variable by itself on one side. All right, so beginning with our first example, we have x plus 7 equals 18. Here we have addition. We want to undo that. So in order to undo plus 7, we're going to subtract 7. Now, in order to maintain equality, what we do to one side, we have to do to the other side of the equation. So I'm going to subtract 7 on the other side of the equation. So now we have x plus 7 minus 7 gives us 0 equals 11. X plus 0 is just x equals 11. Here we have x all by itself on one side of the equal sign. This is the solution to the equation. We are done. Here x with the coefficient of 1 is all by itself on one side equals 11. Now, when solving equations, you always want to check your answers. So I'm going to write here check. We want to check that 11 is the solution to this equation. So I'm going to plug it in for x. So here we have x plus 7 equals 18, replacing x with 11, plus 7 equals 18. Notice I'm using parentheses here. You always want to use parentheses when you're evaluating an expression. It really helps, especially if you're plugging in a negative number. Over here, 11 plus 7 is 18 equals 18. That is a true statement, so it checks. X equals 11 is the correct answer. For example 2, we have r minus 4 equals negative 5. Here the operation is subtraction. To undo that, we want to add 4. And what we do to one side, we have to do to the other. All right, we want to cancel out. We want to make sure here we're subtracting 4, we want to add 4 so that we wind up with 0 here. So r minus 4 plus 4 gives us 0 equals negative 5 plus 4 is negative 1. R plus 0 is just r equals negative 1. Performing a check, we have r is negative 1 minus 4 equals negative 5. Negative 1 minus 4 is negative 5 equals negative 5. So it checks. It is true. In example 3, we have negative 4 plus b equals 45. Now the operation is addition, but look at what we're adding here. Remember, we want this to go to 0. We want to do something that makes the negative 4 go away or cancel out. In order to do that, here we have a negative 4. I'm going to add 4. If you notice, after we do this, negative 4 plus 4 will give us 0. Plus b equals, now what we do to one side, we have to do the other. So plus 4 here. 45 plus 4 is 49. 0 plus b is just b. So our answer, b equals 49. Performing a check, we have negative 4 plus 49 equals 45. Negative 4 plus 49 is 45, equals 45, so it checks. Over here in example 4, we have 3 equals 19 plus m. We want m by itself, so we need to get rid of this 19. In order to get rid of it, we want to subtract 19. So minus 19 on both sides 3 minus 19 gives us negative 16 equals 19 minus 19 gives us 0. So it's gone. The only thing left on the right-hand side is m. So this is our answer. You could also rewrite it if you like the variable to be on the left-hand side. M equals negative 16. All right, either one of these will work. You do still want to perform a check. So 3 equals 19 plus negative 16. 3 equals 19 plus negative 16 is 3. That is true, so it checks. Now in example 5, we have negative 3 times y equals negative 42. So here we need to undo the multiplication. The operation that undoes multiplication is division, so we're going to divide by negative 3. What we do to one side, we have to do to the other, so divide by negative 3 over here on the right. On the left, negative 3 divided by negative 3 gives us 1y equals negative 42 divided by negative 3 gives us 14. On the left, 1 times y, 1 times any number is that number, so y equals 14. That is our answer. Checking. We have negative 3 times 14. On the right-hand side, negative 42. Negative 3 times 14 is negative 42 equals negative 42. That checks. So that is the correct answer. In example 6, we have x divided by 6 equals negative 5. Here we have division. The operation that undoes division is multiplication. So I'm going to rewrite this down here. We have x over 6 times 6 equals negative 5. What you do to one side, you have to do to the other, so negative 5 times 6. Over on the left, we have x over 6 times 6. I'm just going to put that over 1 so we can multiply straight across. X times 6 over 6 times 1, or you can go ahead and cancel here. So on the left-hand side, we have 1x, or just x, equals negative 5 times 6, negative 30. Check. Negative 30 over 6 equals negative 5. Negative 30 divided by 6 is negative 5 equals negative 5. So it checks. In example 7, here we have 3/4 times a equals 8. So 3/4 times a, in order to undo multiplication, we would divide. Since we have a fraction here, whenever you divide by a fraction, remember you invert and multiply. So that is what we want to do. We want to cancel out the fraction. We want to have everything in it cancel out so that we're left with the coefficient of 1. So down here, I have 3 over 4. I'm going to multiply it by the reciprocal. So I have 3/4 a. I'm going to multiply it by 4/3. And what I do on one side, I have to do to the other. So 4/3 times 8. On the left, the 4's will cancel out and give you 1, the 3's, and so you'll be left with just 1a equals. On the right-hand side, if you put 8 over 1, you have 4 times 8 is 32. Over 3 times 1 is 3. So a equals 32/3, which you could also write as a mixed number, 10 and 2/3. Now to check, we have 3/4 times a. Because we're performing operations on a fraction, I am going to use the improper fraction here. So 32 thirds equals 8. On the left, the 3's will cancel, give you with 1. 1 times 32 is 32. 1 times 4 is 4. 32 divided by 4 is 8. So it checks. We are okay. Last one here, example 8. We have 17 equals negative x. Now it looks like this one is almost done. The only problem is this negative sign here. In order for an equation to be solved, x has to be all by itself. X has to be isolated with a coefficient of positive 1. Here we have this negative sign to deal with. So I'm just going to tuck in a 1 here. So the coefficient here is actually negative 1 times x. In order to undo that, I'm going to divide both sides by negative 1. 17 divided by negative 1 is negative 17 equals negative 1 divided by negative 1 gives us 1x, or just x. And again, you could write this as x equals negative 17. Either way, you do want to perform a check. So 17 equals negative, plugging in your answer, negative 17. 17 equals, the opposite of a negative 17 is a positive 17. So it checks.